So for the first question that we have here, I set xy equals to 3 as our equation 1. X to the power of 4, y to the power of 5 equals to 486 as our equation 2. So from 1, I adjusted the y to the other side, then I gotten 3 over y. Substitute it into 2, you will get 3 over y to the power of 4 multiplied with y to the power of 5. So by adjusting the y from the denominator to the numerator, I put a negative to its power, and by combining with the y to the power of 5 over there, you will get 81. Y equals to 486, and your y through the calculation, you will get it as 6. Substitute your y equals to 6 into 3, then you will get your results of x as 1 over 2. So this is actually the easiest type of indices question. Followed by question 2. Sketch the graph y equals to 1 over 5, x minus 2, x minus 4, x plus 5, showing the coordinates of the point where the graph meets at the coordinate axis. Okay, so first thing that I did there was to identify the y-intercept. What I did was I set everything that is x equals to 0, then you will get your y as 8. So the next thing that I did was to identify the interception for x. Okay, so through this I'm focusing on the brackets that is available over there. I get my value of x as 2, 4 and negative 5. So through all these coordinates, I can roughly sketch out the graph. So it will look something like this. So part B, explain why your sketch in part A can be solved using x minus 2, x minus 4 and x plus 5 less than equals to 0. So like I mentioned earlier, when your y equals to 0, the 1 over 5 over there wouldn't mean anything because the 5 after being multiplied with the 0 at the y sides, then it automatically cancel off. Okay, so through this, you will get your respective x-intercept as 2, 4 and negative 5. So part C, they ask you to solve this. You will get x less than equals to negative 5 and x is less than equals to 4 and more than equals to 2. In question 3, find G inverse stating its domain and its range. So a couple of things that you need to know is the G function over there is 2 plus 4i and x, and it was given that the domain of it is actually x more than 0. So in inverse part, this x more than 0 will now change into its range. So first thing that I identified was the range is actually y more than 0 when your G inverse. So moving on, let's try to calculate what's your G inverse here. As per usual, the rules that apply in mathematics applied here. Gx, I change it into y. X and y swap their position. So I got an x equals to 2 plus 4i and y. Rearrange them. Okay, I get rid of the in by using exponential. So e to the power of x minus 2 over 4, you will get it as your G inverse. Then the last part that we haven't identified is the domain of this G inverse. So you can actually identify this through checking the original G's function range. So I set up random points, okay, that is more than 0 into it. It can be 0.1, it can be 1, it can be 3, it can be anything. So through that, you actually get numbers with decimals. Okay, so since it has decimals, then I couldn't use x is actually an element of z, because z represent integers. So what I'm going to use now will be real numbers. So I put it as x is actually an element of r. Part B, solving g hx equals to 10. So I change the hx into x squared plus 4. Substitute this x squared plus 4 into functions gx position. Okay, run the calculation. You will get 4in bracket x squared plus 4 equals to 8. I got rid of the 4. Then in order to cancel off the in over there, x squared plus 4 equals to e to the power of 2. Readjust the variables, shift the 4 to the other side and square root them. I get my final results as 1.84. As for the last part from this question 3, okay, we have finding g prime equals to h prime. So the things I want to point out is, in part A, they wanted you to identify g inverse. So g inverse doesn't equals to g prime. You're required to run your differentiation calculation to get the results of this. So your g prime result should be 4 over x, and your h prime should be 2x. So equating these two variables to each other, x squared equals to 2 and your x will be square root 2. Moving on to question 4. So there's a 2 sine 3 over 2x minus 1. So the 2 is actually your amplitude. So I draw a rough sketch at the top, showing that the highest and the lowest point will be 2 and negative 2 respectively, starting from 0. However, I noticed that there's a vertical translation of negative 1, means it was being shifted downwards. Okay, so what you will have now will be starting from negative 1, reaching at the top at 1, and the lowest point will be negative 3. Then the last part is to calculate the period, or I treat it as a cycle. So I took 2 pi divided with 3 over 2, I gotten 4 over 3 pi, and some of you couldn't identify this 4 over 3 pi effectively, so I converted it back into degree. So to complete one cycle, it will end at 240. The middle point of this cycle will be 120, the peak will be 60 degree, and the lowest point will be 180 degree. So through this, I roughly draw a sketch over here, okay, representing the curve. However, the question is asking for the coordinated axis, which means we are required to identify the value of the graph touches. So it is when y equals to 0 equals to 2 sine 3 over 2x minus 1. Run the rearrangement, then you gotten 3 over 2x equals to sine inverse 1 over 2. So since your result is a positive, okay, it means it's at the first and second quadrant. Okay, it will be 30 and 150 respectively. So divided by 3 over 2, you get 20 degree and 100 degree. So a lot of things was overlapping here. You're required to get yourself familiar with multiple topics to be able to solve this question 4 here. It's kind of tricky for a 4 marks question. Question 5. So when you encounter this type of question, permutation or combination question, you are required to ask yourself the question, did they give you the full details, and thus the arrangement matters. So in our case, part A here, it is surrounding the password. So the arrangement will definitely matters. So this one here we are using P, which is permutation. Okay, first one, there's no restriction, means I can tick 9 of them and use 6 of them as my password. So I put 9P6, then you will get 60,480. Question 2, password consists of 2 letters, 2 numbers, and 2 symbols in that order. So from letters, I have 4 to choose from. So 4P2 multiplied with 3P2 and 2P2. You will get your final result as 144. Part 3. The password must start and finish with a symbol. So we only have 2 symbols over there. So let's say I choose one of the symbol for the front part. I have 2P1 to represent it. Followed by none symbol. In none symbol, I have 7 of them, and I only need 4 letters to fill up the space. So 7P4 for none symbols combination, and the last one is the leftover from the symbol that I didn't use. So I only have 1, so I set 1P1 as the last results. So multiply all these 3 together, you will get 840 as your final answer. Moving on to part B. In an examination consists of section A, 10 short question, section B, 5 long question. So they did give you some brief idea, like each section has how many questions, but they didn't specify, like question 1 is asking 1 plus 2 or 2 plus 3, etc. So this is the part where I consider it as they didn't give you the full details. So when they didn't give you the full details, it means you are using combination. Okay, so for the first one, there's no further restriction. You're required to answer 6 questions from A and 3 questions from B. Okay, this part of the question is telling you that you can select any question, it doesn't matter at all, as long as you answer 6 questions from section A and 3 questions from section B. So we have 10, I choose 6 from section A, multiply with 5, I choose 3, then you will get 2100 as your final results. In section 2, candidates must answer first 2 questions in section A and the first question in section B. So they set up some restriction here. So the first 2 questions, I set 2C2 for it, and I have left with 8 questions, and I randomly choose 4 of them. This is for section A. Followed by section B, they selected the first, there's only 1 first question, so 1C1 for it, and the rest I have 4, I randomly choose 2. So whenever your N and R is the same, it will result in 1 when it is combination. So I automatically cancel them off. Then I took 8C4 times 4C2, you get your final results as 420. Question 6. A particle P travels in a straight line. T seconds after passing through a fixed point. O, its velocity is given as v equals to e to the power of t squared over 8 minus 4 to the power of 3. So they're asking for the speed of P at 0. So 0 is actually the origin, means your time is 0 over here. By substituting t equals to 0, you will get your velocity as negative 27. However, for speed, there's no negative for it, so you're required to just write down 27 as the speed of P at 0. Section B. Find the value of t when P is instantaneously at rest. So what does instantaneously at rest means? It is v equals to 0. So when it is 0, the power of 3 automatically cancel off. Rearrange them. Okay, I get rid of the e by putting in 4. Okay, Multiply 8 to the other side and square root 8 in4. Your result should be 3.33. As for part C, find the acceleration. So you will see me writing this down always at the top. Y dy dx, d2y dx2. These variables represent displacement from the origin, the velocity or speed, and also acceleration. So when they're asking for acceleration, means I need to get the d2y dx2. In short, the velocity over there, I'm required to differentiate it. So through the calculation I bring out the power of 3 to the outside of the bracket, minus of the power into 2. Okay, I copy whatever that's inside the bracket into it. Then I differentiate the value inside the bracket. So we have et squared over 8 minus 4. So from here, I bring out the power that we have over here. Okay, you will get 2t over 8 e to the power of t squared over 8. So when you're trying to differentiate e, the power will never be changed, but you're taking out the powers part, differentiated value. So t squared over 8, after you differentiate it, you will get 2t over 8. So when t equals to 1, you substitute 1 into t's position, you get your dv dt as 6.98. Question 7. Variables x and y are such that log y is plotted against x squared. A straight line graph passing through the point 1, 0.73, 4, 0.01 is obtained. Given that y equals to abx squared, find your value of each of the constant ab. So first thing that I did there was to change up the y into log y. Okay, nothing to do with the x squared because it was already been squared. Okay, that's the things for you to take note. So I put log into a and b and I split them up. So the temporary equation that we got here will be log y equals to log a plus log b to the power of x squared. So in logarithm, you can actually bring out the power. So you now will have log y equals to log a plus x squared log b. So each of them actually represent part of the lines equation. So we have y equals to mx plus c. Our mx here is actually x squared log b, and our c is actually log a. So now move on to step 2. Step 2, what we have to do is to identify the gradient. So I took y2 minus y1 over x2 minus x1. I got a negative 0.21. And this negative 0.21 is actually our log b here. So for us to calculate it, the base is actually 10 to the power of negative 0.21 equals to b. So b will be 0.62. So with this being said, we can now calculate our step 3, which is our a here. So I bring in the y and x value. Let's say I selected x1 and y1. So 0.73 equals to log a plus 1 square multiplied with negative 0.21. This negative 0.21 is actually our log b that we identified earlier. By running the calculation, you will get your results of log a equals to 0.94. A will be 10 to the power of 0.94. So your final results, 8.71. Find the value of y when x is 1.5. So remember the arrangement that we have, y equals to ab x squared. This is where it comes into play. So substituting a as 8.71, b as 0.62, and your x as 1.5, Okay, remember to square it, then you'll get your y's results as 2.97. As for question C, find the positive value of x when y equals to 2. So I put in y equals to 2, put in 8.71, I put in 0.62, and our x here is still remain as x because we're trying to identify it. I get rid of the 8.71, okay, I rearrange this into logarithm, log with a base of 0.62, and the results of 2 over 8.71 equals to x squared. So your x final results will be square root of log 0.62, 2 over 8.71. So this will get you plus minus 1.75. Why is it plus minus? It is because when you put square root, your results will turn out to be plus minus. However, the question specifically mentioned about positive value only, so your final answer should be 1.75. As for question A, okay, so given that the perimeter of the shaded region is 20 centimeters, so by looking at it, I know that I can calculate the arc length AB without any problem. I'm just using the radian formula. However, for us to calculate AB, okay, the first thing that I came up with was to stick with cosine rule. However, by looking at the information that was given, they asked you to show that r equals to 10 over theta plus sine theta. So what this means is that there's no cosine over here. So this basically rule out the options of using cosine to identify the final results. So what you have to do now is to stick with your trigonometry. So I drew down a line from AB joining to the center of a circle. I basically split them up into two identical, okay, literally the same size of the triangle, so that I can distribute the radian, okay, theta as one theta over here and the other theta on the other side. So the AB length is what we are trying to find. So sine theta equals to unknown, okay, I set it for the opposite, over our hypotenuse of r. So unknown will be r times sine theta, okay, and 2 of it will represent AB's length. This is why we have 2 theta r plus 2 unknown equals to 20. This is the equation that I've written down. So by substituting r sine theta into unknown's position, rearrange them, you will get r equals to 20 over 2 theta plus 2 sine theta. Extracted 2 out of them, cancel it off, you will get 10 over theta plus sine theta. And this will be your final results. Moving on to B, given that r and theta can vary, find the value of dr over d theta when theta equals to pi over 6. So r equals to 10 over theta plus sine theta. Okay, this one is the equation that we proved earlier. So the top part, I take it as ux, and the bottom of the denominator, I take it as vx. I find their respective prime, so u prime will get you 0, v prime will get you 1 plus cosine theta. This is actually the differentiation process if you're not familiar with it. Then I use quotient rule. Okay, through this, I gotten 10 bracket 1 plus cosine theta over theta plus sine theta bracket square. So I substitute the pi over 6 into it and run the calculation. You get your final results as 17.8. Question 9. This is actually vector question. Literally the same from your mathematics, just they like to add in additional unknowns to confuse you. So from D to B, it's actually DC plus CB. So DC is 7A, and then we don't have CB's value, but we do have BC. So by changing the direction means you have to add a negative to the B. So your DB's value will be 7A minus B. As for DA, it will be DB plus BA. So DB is actually what we identified earlier, which is our 7A minus B. And BA here, we only have AB, means that we have to add a negative into it to change it into BA. So what we have now as the final results will be 3A minus B. Given that AX equals to unknown AC, so we're going to rearrange this. Okay. So AC is actually AB plus BC, so it will be 4A plus B. So by substituting 4A plus B into AC's position, we are able to identify that AX equals to unknown bracket 4A plus B. DX on the other hand, okay, nothing much, it's also the same thing. So DA plus AX, DA is what we identified earlier as 3A minus B, and AX is the C's value. Okay, substitute it in, then you get your final results. So if you notice, if you screw up the previous part, it will have a domino effect and make you lose the entire question. So this is the thing about maths. You have to make sure that your answer is correct from the start so that it won't have the spillover effect on the rest of the question. For question E, find the value of these two unknown here. So dx is actually 3a minus b plus unknown bracket 4a plus b. And this entire thing equals to the other unknown with the db value of 7a minus b. Multiply it in, rearrange them. Okay. I categorize A as one part and B as one part to run the comparison. So for the left hand side of the equation, I got an A bracket 3 plus 4 unknown bracket minus B bracket 1 minus unknown. So with this arrangement, I can now compare the variables inside the brackets. So 3 plus 4 unknown equals to 7 special unknown. And the other part will be the comparison on B will be 1 minus unknown equals to the special unknown. Substitute it into the equation. Then you will get your first unknown's value as 4 over 11. And with this 4 over 11, you can identify the special unknown as 7 over 11. So I couldn't think of the way to pronounce these two variables here. If you know it, feel free to leave your comment in the comment section and let me know the actual pronunciation for these two mathematical terms. As for question 10, sketch the graph. So when it comes to sketching the graph, I always stick with a few rules. I first identify their x-intercept and y-intercept, followed by 1 and negative 1 for the x value. Then I will set one extreme value to prove that which direction the graph is actually growing. So when your x is 0, your y will be negative 4. This is actually your y-intercept. And when your y is 0, your x-intercept is actually in5. So the other thing that we have there was when my x is 1, you will get negative 2.3. This shows that it is going upwards when my x is positive. Then when my x is negative, it continues to go downwards. So I set an extreme value for the negative part. So I set negative 1000, then I'll get to negative 5. It will stagnate from there onwards. So now you see me draw a dotted line of 5 over here. This dotted line, you don't have to draw it out. It's just for your own illustration. So from the curve, I touches in5. Then I join to the y-axis of negative 4. then it goes closer and closer and closer to the -5 that I drew over there. You don't have to touch -5 straight away. It's just an illustration that the line is actually getting closer and closer to -5. So part 2, find the range of value of k, which equation e to the power of x minus 5 equals to k has no solution. So anything that is lesser than -5, we have no solution because the line wouldn't go any further down. So it only stops at 5, whatever that's below it won't have any answer. So this is why your answer is actually k less than equals to 5. As for part B, we have logarithm question here. A couple of things that I did was to change the square root 2 into 2 to the power of 1 over 2. And I changed the 8 into 2 to the power of 3. And I shift out the denominator of 2 to the numerator, so I add the power as -1. So now that all of them has the same base, okay, I multiplied them all together because in logarithm, plus means multiplication, and also the variables inside is actually has the same base. So I just basically run the calculation on their power. So I have 2 to the power of 1 over 2 plus 3 minus 1. So through this, you will get log with a base of a 2 to the power of 2.5. And this 2.5 can be extracted out and it represents p's value. This is your final p, which is 2.5. You can leave it as a fraction, you can leave it as decimals. Both is accepted. Whereby for C, okay, you notice that their base is not the same. I wouldn't change log 3x into log 9, okay, because that's not my standard practice. My standard practice is to change all the numbers to the smallest as possible. So by changing the base, I gotten my log 9 4x into log 3 4x over log 3 9. The other thing that I did was to change the 1 at the end as log 3 3. So now that all the base is 3, I then calculate the log 3 9 that I have as the denominator. From this, you will get the results as 2. Okay, and this 2 here, I can actually write it as 1 over 2 times log 3 4x. And whenever there's variables in front of the log, I can then bring it up as my power. So what we have now will be log 3x minus log 3 4x to the power of 1 over 2 equals to log 3 3. Minus represent divide, so I have log 3x over 4x to the power of 1 over 2 equals to log 3 3. So now both sides has only one log only, so I can proceed and cancel them off. So what we have now will be x over 4x to the power of 1 over 2 equals to 3. Remember, the power of 1 over 2 is to be multiplied into the variables inside the bracket. So the 4 you're required to power of 1 over 2. So the x also required to multiply with power of 1 over 2. So what I did next was to shift away the 2. So we got x over x to the power of 1 over 2 equals to 6. So I bring the 1 over 2 up by putting a minus over there. The 1 with x only is actually x to the power of 1. Okay, this goes back to your indices concept. X to the power of 1 minus 1 over 2 equals to 6. X to the power of 0.5 equals to 6. So to make it into x, I multiplied the 0.5 with 2. Same goes to the 6. So I'm required to square the 6 as well. So your x final results will be 36. As for the last part, 11a, cosec over cosec minus sine equals to sec squared. Alright, so first thing that I did was to change the cosec into 1 over sine, and then the long line over there, I usually write it as the symbol. So I write divide, So the cosec I change into 1 over sine minus sine. Okay, so I make their denominator the same, okay, for the brackets. So I get 1 over sine divided by 1 minus sine square over sine. So through this, divide become multiplication. I got 1 over 1 minus sine square. So this 1 minus sine square can be changed into cosine square, and 1 over cosine square is actually your sec square as requested by the question. So this is how you convert this and get your final results. So they ask you to solve 2 cosec over cosec minus sine equals to 8. So the only difference between this part 2 and part 1 is there's additional of 2. So I can actually write this as 2 sec equals to 8. Sec equals to 4 because I got rid of the 2 to the other side. Sec can actually be changed into 1 over cosine square equals to 4. Cross multiply them, and I put a square root in order to cancel off the square effect. So whenever I put square root, it will be plus minus the results. So what does this plus minus means? Means that all 4 quadrants will have results for this cosine here. So we have 60, we have 120, 240 and 300. So I drew it at the side so that you can refer to my workings. As for the last part, okay, special part about the bracket is that it was changed into x plus pi over 4. So this will immediately affect the range that was given to us. So 0 plus pi over 4, you get pi over 4, and the 2 pi plus pi over 4, you will get 9 over 4 pi. Okay, so this is our new range now. So I get rid of the square root 3, tangent x plus pi over 4 equals to 1 over square root 3. Okay, I try to identify x plus pi over 4 equals to tangent inverse 1 over square root 3. So key in your calculator, remember to set it into radian mode. Okay, because what we have here is in pi form and the previous question is in degree form. So do take note on this and don't make silly mistake on this part. So after changing your calculator mode into pi, key into your calculator, you will get the results of 1 over 6 pi. However, this result is not accepted because it's actually lesser than the range that we have over there. So this 1 over 6 is excluded, and I can now proceed with the next calculation. Okay, your 1 over square root 3 is positive, so you only have results in the first and the third quadrant. So the first one, we already got rid of it, so we skip that and proceed to the third quadrant calculation. So I took pi plus 1 over 6 pi. So through this, I will get 7 over 6 pi, and do not miss out the last part because the range actually extended. So your cycle doesn't end when it touches 2 pi, it actually continues to extend. So what this means is that, remember the 1 over 6 pi that was disqualified earlier, you can now take 2 pi plus 1 over 6 pi to identify your next possible results. So through this, you will get 13 over 6 pi, okay, minus your pi over 4, then you will get your results as 11 over 12 pi, 23 over 12 pi. And this will be your final answer. So that's pretty much it for this specimen paper, paper 2. I hope you find the explanation helpful. If you're looking for the specific topic explanation video, I already made a few now, so you can actually move on to the video library and access to it if your fundamental is not strong enough. So that's pretty much it for this paper review. If you have friends that are struggling, feel free to share this paper to them, and I wish you all the best in your upcoming examination. Thank you.